Hello, welcome to our little corner on the web, where we hope to develop and nurture a love for math. Today, we're going over question 5 in part 3 of the 27th PMO qualifying stage. Sorry about that. Thank you to organizers for publishing their questions online. Okay. So the 27th PMO qualifying stage, question 5 in part 3, asks or states that let P1 through P27 be a regular 27 gone. How many triples of positive integers ABC with 1 less than or equal to A, less than B, less than C, less than or equal to 27 are there such that PA, PB, PC is a Q? Okay. So for those who want to try it first, feel free to pause here before we dive into the questions. Okay, so diving in. So since it's a regular 27 gone, what we can do is think about this as if it was enclosed in some circle. Okay. And the P1 through P27 are arranged in order. Okay, dot, 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 all the way to P27. What you'll notice is for a triangle to be acute, if P1 is included, we can draw the diameter on it, including P1. And one point has to be on the right, and another one has to be on the left. Okay. So it can't all be on the same semicircle, I guess is one way to phrase it. So for example, if we have a triangle that includes P1, P2, then that means we also have to draw the diameter from P2. Okay. And there's actually only one point across that will satisfy that. Okay. So the one that P1, the diameter with P1 will divide it such that P14 is on one side, okay, and P15 is on the other side. Okay. The diameter with P2 will divide it so that P15 is on one side of it and P16 is on the other. So if P1, P2 is included in our triangle, then the only triangle that will satisfy that is P1, P2, P15. Okay. So that means that we actually have to be a little careful if we want to build up the cases from the ground up. But that's sort of the first solutions I'll show you, and then we'll try to look at a different solution as well. Okay. So note that we basically want points on different parts on different sides of the two semicircle. Okay. So I'll for reference, I will put a circle here and just so that we can keep track of things or when things get confusing. So the first time I saw this, I basically said I'll use gaps, meaning the gap between P1 and P2 or P1 and Pn as my cases, so that hopefully I can be a little bit more careful and not overcount or undercount. I know it's a little bit more tedious, but what I always tell the kids who are taking PMO is if you see a question that you think you can solve, if you don't see the elegant solution at first, it's okay to use whatever means that you can think of initially. And if you can counter check later with a different solution, then all the better. Okay. So here, what I said was, let's use gaps between the first 2 points that we choose, meaning PA and PB. If the gap is equal to 1, okay, then, for example, if we start with P1, P2, then there's only one point that satisfies it. That's P15. Okay. And if you start with, just as we discussed a while ago, if you shifted that point to P2, P3, then there's P16. Okay. And so on and so forth. For me, I built up the case until I reached P27 as my last point. Okay. So that means that I came from P13, P14. Okay. So in these cases, there's basically 13 times 1, right? 13 ways to do this, and one other way to choose that. So that was 13 times 1. And I stopped there because I didn't want to go through P14, P15, and be matched with P1. Because later I will analyze gaps where gap equals 13. And this thing will show up as 1, 14, 15. Okay. So I stopped short. Basically, I will do a lot of stopping at P13. Okay, sorry. Actually, P14 as the last upper point. Okay, and then analyze the cases separately after that. So in the case of P1, P2, or gap equal 1, there's 13 times 1 case. Okay. And then you'll see that there's actually a neat pattern that will sort of show up here. Okay. So this is 13 times 1. Okay. So for gap equals 2, then the points that we're really worried about, okay, or at least we'll try the first few points again. So it will be P1, P3, but now instead of just being able to add P15, we also have P16 as an option, right? So this is now an OR. Okay. So we can keep going up. P2, P4 will be P16 or P17, all the way again until we reach P27. Okay, so P26, P27 will be paired with P14, P12. Okay, so here there's 12 ways of choosing this part and 2 ways of choosing that. So 12 times 2. So now we ask ourselves the question, what happens if we go slightly above P12, P14? So P13, P15. Turns out that it should be P27 or P1 as the option there. But again, P1, P13 will show up later when we do gap equals 12. So we want to exclude that. So really, we're missing a case here of a +1, where we have P13, P15, P27. Okay? And then the next case will be gap equals 3. Okay. And that will be P1, P4, now with P15 or 16 or 17. Okay, P2, P5 with P16, 17, or 18. And we can go until P27, 26, 25. Okay, and that would be with P14 again and P11. Okay. We can ask, again, here there will be 11 choices for the initial pair, times 3 choices for the third vertex. And then we ask ourselves the question, what happens if I go higher, right? P12, P15. Well, it will be P26, 27, and P1. And same as a while ago, we don't want P1 because that will be overlapping when we do gap 11. And then we have P13, P16 is P27 as the desired leftover. So here we have a +3. If you keep doing this, you will actually end up with triangular numbers as the leftover cases. And the product will be actually the product of 2 numbers which sums to 14. Okay, so the pattern actually nicely fits, meaning if I keep going, the next one will be 10 times 4 plus 6, 9 times 5, plus 10. So we can actually just write it out. Gap 4 equals 10 times 4 plus 6 then 9 times 5 plus 10, 8 times 6 plus 15, all the way to 1 times 13 plus 12 times 13 over 2. So this is building up the cases with no overlaps at all. So you will find that the first column here, I just basically summed it as normal. That's 455. And on this side, you might know or remember, if not, this will be a good place to learn, that triangular numbers can be just summed as n times n plus 1, n plus 1, n plus 2, all over 6. So we end up with the 12th triangular number being 12 times 13 times 14 over 6. Cancel, cancel, 2. So this is 26 times 14, or 260 plus 104. So this is 364. So we add 364, and that's how we end up with 819. Okay. So that was actually a long way of attacking this problem. So you might be asking, what's a shorter way? Okay. So the shorter way, I'll delete all these things. The shorter way actually ends up being, imagine a circle, and instead of counting the acute triangles, let's count the obtuse triangles. So the obtuse triangles have to stay on one side of that circle. So there's 27 possible starting points, P1 through P27. And if we just count the clockwise direction of where the 2 points would be, right, there will be 13 points on this side, and we need to choose 2. 13, choose 2. Okay. It turns out that by doing this, there's no overlaps anymore. I mean, if you counted the other side as well, then yes, you would have double counted everything. But we just needed to do 27 times 13, choose 2. Okay. For the number of obtuse triangles. So we remove the obtuse triangles from the total set. The total set of options will just be 27, choose 3, right? Choose any 3 points on that circle, minus 27 times 13, choose 2. And here we basically have 27 times 26 times 25 all over 6. Cancel, cancel, 13. Oh, sorry. 13 and 3, cancel this one here. That'll be 9 minus 27 times 13 times 12 all over 2. Cancel that, that becomes a 6. So factoring out the 13, it becomes 13 times 9 times 25 minus 6 times 27. So it's 13 times 225 minus 162, or 13 times 63, which is equal to 819. Okay. So either way you did it, that's perfectly fine. And again, not all you won't see the elegant solution all the time. But as you see more and more problems, then you will get better at it. But in a competition like the PMO, if you can find a problem that you can solve, even if it's the long way, go for it. Okay, just be extra careful as you're doing whether it's casework or calculations. Okay. So hopefully these two solutions, one of them sort of made sense. If you found this helpful and educational, do hit the like button and subscribe. Again, thank you for watching.